everybody, welcome back to Organic Chemistry 2. Today we're going to do experiment 28. We're actually going to make banana oil. This is one of my favorite labs. It works really well. It is straight out of lecture. We're going to do a Fischer Esterification. We are going to start from acetic acid. We are going to add isopentyl alcohol, and we're going to catalyze it with acid. And in a Fischer Esterification, remember these reactions are in equilibrium. And so it matters how we set this reaction up in order to propel our reaction forward to make the ester from the acid. So we're going from a carboxylic acid to an ester. So when we set up this reaction, we're going to keep that equilibrium in mind. When we're moving forward from an acid to an ester, we need to do a couple of very important things in order to skew that equilibrium. The first thing we're going to do is heat our reaction, reflux, and then distill. Our ester will have a boiling point that is allowing us to distill away our product as the ester and leave behind our acid and our alcohol. And then number two, we're going to acid catalyze, but not add additional water. So there will be a small amount of water present. Anytime you add sulfuric acid like we are, there's some water in there. So we want to drive our reaction forward. So we're going to set up the first part in order to heat that reaction and drive our Fischer Esterification forward. So we're going to set it up using a reflux setup, and then we're going to distill our product. We're going to try and remove our product from our two starting materials. So we're going to start actually with 150 millimoles of our isopentyl alcohol. That's quite a bit. In fact, that will be our solvent. That is one of the ways we're driving this reaction forward. Our alcohol is our solvent. We're going to add our vinegar or our acetic acid, 17 milliliters. All our liquids, nice and miscible. Now this is concentrated or glacial acetic acid. I'm going to keep it in the hood, and I'm wearing gloves. It has a prolific smell. It also can burn skin. Then I'm going to add concentrated sulfuric acid. This is as strong as sulfuric acid gets. This is 18 molar. There is still some water present, but it is an awful lot of sulfuric acid. We're going to add as a catalyst our sulfuric acid. Now before we set something to reflux, we also need to add boiling chips. We need a surface for our reaction to start boiling and refluxing. So I'm going to add a little bit of boiling chips. So I want to get this whole mixture heating. I'm going to give a little swirl. It's already warm to the touch. So I can tell something is happening. I want to set this up to reflux, meaning I want to trap all of the vapors and have them actually condense in my tube and drop back into my reaction mixture. This is reflux. So I'm going to turn on the water. I want to condense any vapors coming from that distillation. Let's get that straightened up there. And then as in all of our reactions that use the heating mantle, I bring the heat to the reaction, not the other way around. That's a safety measure. In case something happens with this reaction, I can drop the heating mantle fast and remove it. So I'm going to go ahead and raise up the heating mantle. I'm going to make sure that heating mantle is physically touching the flask. Then go ahead and start heating. Now because we've added just a little bit of water with that sulfuric acid, I'm not worried about water vapor in the top of the reaction, so I'm going to let this reflux open. means we are condensing all of our vapors back into our reaction. But remember, the point of this reaction is actually to use Le Chatelier principle and drive our reaction forward. So we're not done. We've just been refluxing to form our ester. Now we want to drive our ester over in a distillation and try and isolate the ester and leave behind our alcohol and our acid. So I'm going to slowly lower the heating mantle until it's cool enough just to touch, and then I'm going to swap the reflux condenser for the distillation apparatus. We'll let that cool for a second, and then we're going to swap our glassware. Okay, we've cooled enough that we can touch the reaction vessel. I'm going to leave my heating mantle because we need to heat again. I'm just going to move it out of the way. I'm going to swap the reflux condenser for our simple distillation setup. So again, we want to drive our reaction forward. So we're going to set it up as a simple distillation. We may not need that kick clamp. I'm going to need a thermometer in here. I'm going to want to set up my water hoses here, and I need to collect here. We're going to collect our product there. I'd like to put a jack under there. And out on the bottom. Wait, say that again. We want to go in on the bottom and out on the top for our water hoses. Let's turn our water on, just gentle. My heating mantle. And get this distillation started. I'd rather not have my hoses here, so I'm going to put the hoses in the back, but I wanted to get the distillation itself started. sulfuric acid, and we're collecting quite a bit of product in here. We don't want to go too far, you know, we don't want to distill for too long and end up with a lot of alcohol or acetic acid coming over. So we're going to go ahead and stop it. Looks nice and colorless. We've got a lot of product. I'm going to turn off the heat and lower the condenser. Just get that heat source out of the way, and then we're going to let this cool before we turn off the water. And then our next step is to take this product. We want to make sure any residual acid is gone. So we're going to take our product and put it in the step funnel. So we're going to continue our banana oil experiment. After our distillation, we collected our crude material from our distillation. We still need to purify. We had acid present in that equilibrium reaction. We drove that reaction forward, but we may have some residual acid. So we're going to put our product in a step funnel. Let's take a second to use some proper step funnel techniques. First of all, I'm going to double check that my septa is perpendicular. When in doubt, always put a flask under your step funnel. You worked hard for that product. You don't want to lose it by spilling when you dump into your step funnel. So I'm going to go ahead and pour my crude product in the step funnel. If by some chance I had forgotten and this was open, we would have collected it anyway. I'm going to go ahead and rinse the flask with water. The first step in our procedure is actually to isolate our organic layer from our water layer. We're going to actually add DI water and wash out whatever residual acid we might have. So I'm going to add 50 mils of DI water. You should see two layers. We should have a product layer and an aqueous layer. If you're ever in doubt which layer is which, you can always add a little water and see which layer gets bigger. The bottom layer got bigger in this case. So whenever you use your step funnel, you also want to stir and agitate. Our step funnel on purpose has this shape so that we can invert and bend. So we're going to shake it and bend it. We should see two layers re-emerge. Do you notice that top layer is pretty small? That's our organic layer. Like I said, you can always check your densities, or you can add a little water to double check your layers. I'm going to go ahead and drain off the bottom layer. Now we want to wash that aqueous layer with sodium bicarbonate to make sure we've really neutralized any residual acid we may have. We used a pretty strong acid in our distillation. We want to make sure we remove that. I like to slow down when I'm getting close to that line. Then I typically stop when I'm just shy, and I turn my valve nice and quick. And when I do that, I'm just letting out maybe a drop at a time, and then it's a little bit easier to catch just the organic layer. Actually, I'm going to leave that in. I'm going to add the first aliquot of sodium bicarbonate. Whenever you use sodium bicarbonate in your step funnel and you're dealing with residual acid, you have to be careful to vent. If you have acid present at all, you will don't make carbon dioxide, you will build pressure in your step funnel. So it's really important that by the time you put your top on, you actually work pretty quickly to invert. And you can actually see the little bubbles come up in the step funnel. We are venting that carbon dioxide. Aha, my penny stopper is stuck. This is my favorite. Hang on, I'm gonna grab a tool. Okay, sometimes I surprise myself with my strength. And I put the penny stopper on just a little bit too forceful. So I'm gonna just give it a nice little smack with something Teflon while I pull up with my finger. All right, now we can drain that bottom aqueous layer. Again, I'm gonna stop just shy and go ahead and turn quickly and get to just my aqueous layer. I'm gonna do that one more time just to make sure. Remember, one of our reagents was acetic acid. We want to make sure we get rid of all of that. Give it a nice vent. Flask. We definitely have had residual acid in there. That is our carbon dioxide bubbles. Now we want to take our actual banana oil, and we still have some water left in there. We want to run a GC on our banana oil. We want to make sure all of the water is gone. Between GC and IR, we don't want water present in our sample. So we're going to take an additional step of using magnesium sulfate to dry this top layer. So I'm going to grab a small Erlenmeyer flask, use magnesium sulfate, and filter. All right, let's take our organic layer and let's empty it into a nice small flask. We've got a pretty small volume of our product, so we want to keep that in a small flask. I'll let that drip for just a second. And then let's add a little scoop of magnesium sulfate. Now with magnesium sulfate, you're really aiming for a snow globe. You're going to add a little scooper and give it a swirl. Do you see the clumps? The clumps are water. That is magnesium sulfate has soaked up that water. So if you look down on it, all we have are clumps. We're going to add a little bit more. The secret to mag sulfate is that you add it until you've got flakes that are free floating, like a snow globe. Then you know you've soaked up all the water. Oh, we still have clumps. Clumps only. No Hallmark channel yet, no snow globe. Still only clumps, so let's keep adding. wanted to get all of it, as much as we could. We maybe wouldn't filter with such a big filter paper. We would use the pipette filter like we've done in a previous experiment. But for this experiment, we really just want to run a GC and see the purity of our compound. And so I'm going to go ahead and filter through filter paper, knowing I'm probably going to lose a little bit of my banana oil. I do not rinse the flask because this is pure banana oil now. I don't want to add anything to that. We can also smell check and see if we're on the right track. Our starting materials smell pretty not so good. Our glacial acetic acid should be a vinegar smell, but very potent. And then of course we've made banana oil, so it should smell like banana Laffy Taffy. Absolutely. Now we just let this filter, let it drain.